Right folks, well we've got another Amstrad here from our trade customer who's got a fleet of lorries all with Amstrads. This is a Hong Kong Amstrad, so is it going to be the real Hong Kong Amstrad or the El Cheapo or the fake one, whatever we want to call it? We can't tell till we open it up. It's got the power connector you can't get, but it's come with the lead, so that's good. It's immaculate considering the age of that. Right, so we'll start writing things down. So the question I did put to you on the last video was, shall we fit a CB in this replacement of 19-year-old vehicle, because we're getting rid of our 27-year-old Toyota. We've got a 19-year-old Nissan instead. They have to be old to come into the price category. So the answer is yes, it looks like we're going to be buying and fitting a Thunderbolt T3000. Where have I put the pen? 2nd July, and it is Amstrad 901. Serial number is a peel-on label rather than engraved in. So let's see what happens when we open it up. There's two versions of the Hong Kong one. Hello, printer. Hello. So if it's the proper Hong Kong one, the £59.99 one, then it has a screen printed circuit board inside. If it's the El Cheapo fake one, it doesn't have any screen printing on it, and it's the £29.99 set. Well folks, it's the real McCoy. Mind you, it's had that. I wasn't expecting that to be soldered. So I've not seen one of these. I've not seen the genuine Hong Kong one for years, only the El Cheapo one. And when I say I've not seen one for years, I probably haven't seen one for 15 years. Oh. Well, that's good news. You shouldn't have the squelch shenanigans that you have with the cheap one. That's the only letdown on the El Cheapo one. Squelch and overall reliability. It uses cheaper components. Right, well, may as well use the... Now we won't use this mic because we'll certainly test it at the end of the video. You know, that's what I'll do. But so this is the power lead which you can't get. We end up taking those off and putting the square round other type on, which is on most of the Amstrads. So the question here, it's the usual thing, is it going to be the 3-watt ballast resistor here for the transmitter, or is it going to be a bit meaty, because unless this radio is doing 3.6 watts, we're going to need to change the ballast resistor. You can't expect something which is 3-watt rated to enable the radio to do 4 watts. That's just the problem. Right, we'll get it powered up. I don't think it's particularly faulty. I just think it needs a service, and that's what we're here to do. I've only had the test gear on 10 minutes, so we'll take everything with with a pinch of salt, with what it tells us on things like frequency. So have I got a mic on here? Yes, I have. We have a Cybernet mic. So we won't use the customers to actually do the job. Power supply on, 13.8 volts. Switch the rate, let's take the bottom off. Switch this on. Channel 20, squelch to minimum, tone to medium, RF gain to full, Roger bleep off, channel 9 off, public address off. Connect it up to our test equipment. At the same time I'll plug in the extension speaker so we can test the PA. So that's PA speaker in, and that's the test equipment speaker. I'm going to switch to PA. Testing 1 2, testing 1 2, testing 1 2, 1 2. Sounds a bit awful. And then we'll test it with the customer's mic. So we're testing the mic, testing 1 2, testing 1 2, testing 1 2, and that has got a dirty PTT. It feels like the moulding's broken, or it's just loose. It ain't nice. As I've always said, we'll look into that later if there's time. As I've always said with these, it's great having the original mics, but these are 40 years old. They're very much the weakest link. And if you've got a working original mic, keep it in the box and just use a new mic when you're actually using the set. So the first thing we need to do with anything using this chassis, we'll need to do the VCA. We're going to run through the parameters. Switch picture in picture on. Let's put it there. Put it there, partner. So we'll start off on the 3 watt scale. I'm on channel 20 when we get back to CB. We must be in low power because it's tiny. There we go. It's just on the 3 watts. I'll just check on the other scale. Yeah, it's 3 watts exactly. Channel 40, 3 watts. Channel 1, 3.1 watts. Back to channel 20. Low power, 150 milliwatts. Back to full power. That isn't adjustable, but it will change when we redo the transmitter. Hello. I didn't take. There we go. 1.29 amps, 1.291. Deviation. Wow, low. That's very, very low. It says 1.4. We'll be checking this with the test set behind me in case the Mark only one's lying, which it sometimes does. We'll come back to that in a moment. What we need to do is frequency. So we'll put that over to the frequency counter. Some of these now are at such an age that they won't pull up and the crystals need replacing. So as long as it's over 79100, we're all right. It's it's still legal down to like 78125. You can be 100 out. Right, 2779090. So it's not too scary. I'll tell you what, we'll pull it up right now, unless it's broken, of course. It will come up a bit higher as the test equipment warms up. Not because the radio will come up a bit higher, but the test equipment reads low when before it's come up to operating temperature. So we've got that at 2779106. That's fine. So we're not going to have to replace anything like the crystal, but I say we'll check it in half an hour. And to that end, we'll set the signal generator to 27. We were on CPT, weren't we, yesterday? 2779126. Oh, it's not 126, it's 106. What am I talking about? So there we are. So we've got the frequency matching what the radio is. That actually sounds all right. It's 100 microvolts, and it's showing as S9, exactly like it should do. Doesn't have a meter lamp. Switches work. Potentiometers work. They're not noisy. Sockets work. PA works. We're getting down the list, aren't we? So on transmit, we know it's doing 3 watts, and it's reading 5 bars on transmit power, which is bizarre. Frequency, it was 27790, was it 90, something like that. It's fine. Right, so let's see what the receive sensitivity is. We'll put this onto the cyanide meter and put some volume on so we get a reading. Very good. So for 12 dB it's 0.35. For 10 dB it's 0.28. For 20 dB if it'll do it, it won't on that scale. Ugh. It's 10 microvolts, that sounds like the detector's a bit out. Squelch sensitivity, let's put that to full squelch. And I'll go to the attenuator on this screen so you can see what's happening. So we're at 0.3. I want it, the squelch to open when it's on full. It's 100 microvolts. So it's 0.3, 1, 3, 10. It's opening at 10. So let's get an accurate reading. It's actually opening at 9, which is too wishy-washy. It may not adjust. We'll see. We can't always get the same performance out of the 59.99 one like you can out of the 89.99 Japanese one, as you well expect. Right, so on the minimum squelch, let's get the squelch threshold. That actually does need squelch control clean. That seems to be the threshold. No, it's not. Try again. It's coming in at 0.3. So that's done all our preliminary things. Now, have I got enough of the service manual extract to do this? Yes, I have. VCO. Can't remember whether it's a floating chassis or whether we have to let's have a look. Test point is there, and we need to, I think we need to add channel 1. Yeah, channel 1. I don't know whether that's the earth point or whether we'd just go on a can like that. Even better if we get a connection onto that capacitor. And get the VCO adjustment there. .02. Let's go back to receive. 1.9. So just do the coil there. We've got 2 volts there we've got 2 volts there. That's what we want. So now we need to check on channel 40. Now what it says in the manual is a bit not quite right with experience. It needs to be over 3. So I'll try and hold that back on. Let's go to channel 40. It's 3.5. They say it needs to be between around 4, 4.5, but it's a bit high, that. This is actually correct. There we go, that's fine. It doesn't specify what meter they were using. You know, it could have been an AVO 8, which is the industry standard instrument, especially at that time. And so it's going to be a bit different using an electronic meter. So let's just jot down. I've gone and put away that with the circuit. So it's now 2 plus 2. So we're done. Now if you don't do that, you end up with channels dropping off, especially when the temperature, you know, you get in your car, it's baking hot, and you find no channels under number 10 work, or no channels after over 30 work. That's what happens if the VCO is not attended to. Or the opposite happens when it's cold. So we'll go through transmit and just see if we can get the magic 3.6 watts, or whether we're going to have to change that ballast resistor for a bit of a more hefty one. So I'll go to the other scale, because we are at the end of the 3 watt scale. This is the 25 watt scale, 30 watt scale. Business radios in this country, maximum power is usually 25 watts, which is why the test instrument has is a 30 watt scale. So that's no difference with that one, so that's in the correct position. We're looking for the centre of the peak. A slight difference there, not a difference to power, but a difference to its position. Oh yes, now that one was out. The one thing, it's been run at 3 watts all its life. It's not exactly been thrashed, has it? No, that's it. That's it. Ballast resistors have to be changed. It ain't going to do it, folks. Wherever it is. That's one end. That's the other end. Right, we'd better see whether we've got some kicking around. So these are 6 watt rated rather than the 3 watt rated one, and yet the size is no different. The sleeving off. So if we compare, the virtually the same size. In fact, the new one could be smaller, and this is 3 watt rated and this is 6 watt rated. So you can see it's got a fighting chance to develop 4 watts if the ballast resistor actually allows that kind of current. So they really should be capable of doing 3.6 watts. It doesn't make a big difference to the range. You know, whilst you're entitled to 4 watts, you may as well have it. Good. It's not as neat a job. We're going to go with this with isopropyl alcohol, but it's not as neat a job, the finish of this, than the Japan version. Right, so moment of truth. Let's put the power back on. Its absolute maximum peak is exactly 4 watts, which is fantastic. Right, hope it's within 0.1 on the other channels. So on channel 1 it's 4 watts, channel 40 is likely to be a little bit less. I'm quite right, it's 3.95. Right, back to channel 20. Current consumption is now 1.456. And the low power is now 180 milliwatts. Now the leaves are on the trees, I don't think we'll be getting through on to Scratchy Corner on 180 milliwatts 5 miles away, but it's always worth a try. Right, we'll do deviation right at the end because of me using the test. I'm just going to set it for now with this test set. Look, there we go, that's set for there. We'll test it to sound the other test set at the end. Right, the meter was already banging off the end before I changed the ballast resistor. There's the preset. So it should read 4, which it does. And on low power, it should read 1, which it doesn't. So I need to readjust that till it does. Let's go back to full power. That's not full power. So I can't balance it. It says 5. It's not faulty, it's just cheap. Mind you, at least it's got a power meter, hasn't it? We did that Midland 38 yesterday, which was one of the first sets to have a fake power meter. And I mean, they're all fake power meters. I think you can still get a Midland 78. They've got a real power meter, but everything else is a fake power meter. It's pre-programmed to do a bar graph. You can take the output transistor out, and it still says it's doing so many watts. So it's absolute BS. I don't know why they've done that. Well, I do know why they've done that. They've shown people what the radio shows people what they want to see, and that's a big bar graph going across. Doesn't mean it's doing anything. Right, so we've done that. So we'll get on with the receiver. So we're going to start with the detector. We want 100 microvolts on the signal generator. There's the oscilloscope. Detector is there. It was already spot on. Alright, let's look at sensitivity. We'll go to the cyanide meter and see whether we're going to get any more out of this receiver. And the answer is yes, we are. Drop the attenuator, so we're lessening the signal. As we improve the tuning of the radio, we need to drop the signal generator for it to be meaningful, or you end up saturating the receiver. Then when we get to the IFs, we may have to jack up the signal. That was spot on. Let's see where we are. I'll just put the signal generator up. Funny enough, that was out. And we've got a hidden one down here. That's fine. Right, let's get a new set of readings. So for 12 dB, we're on the wrong scale. I'm on a more sensitive scale. Right. Wow, 0.24. This is good. For 10 dB, 0.2. Let's see whether. Let's hope we've improved that. We have. It's 2.4. This is only down to noise. This doesn't really matter. Right. So having done that, let's see whether we can get the squelch something like. That would be nice. So let's put squelch to full and see if we can increase this preset. We'll start it off at full and see whether that's good enough. So showing you the attenuator, once again we need 100 microvolts to open that, and it was 9. So we're at 3, 10, 30, 100. It's far too coarse. So we'll drop this preset till the signal comes in. That's there. There we are. That is set for 100. Excellent. That's what we want. You can't do the you can't get this on the cheap Hong Kong one. That's much better. Right, now we'll do the opposite. Check the sensitivity. It was 0.3 before. I'd expect it to be something like 0.7, to be honest. Turn the signal generator off, set squelch threshold. Signal generator back on. It's parked at 0.3. Still 0.3. Oh. Well, that hasn't changed. Wow. That S meter, it was right before, but of course we've retuned the receiver. So we've now got S9 on the signal generator. It's showing 5. So it's changed it. Preset is just there. There's 9. So we need it to open. I need it to be on the verge, I think, of the next bar. Let's have another go at that. So I've got it to the plus 30, which isn't a plus 30 signal. I'm just going to drop the preset so it's just not lit. Now I'm going to increase the signal generator. As you know, it's 100 microvolts. Yeah, it's going to be like that. So just check with our walkie-talkie that I can't open it with the signal generator, but we'll just check with the walkie-talkie that with a close proximity signal it goes to plus 30. The answer is no, it doesn't. So once again, we'll adjust the preset. So that is just plus 30. So it's now not quite, it's now being a bit generous. It's what, 38 microvolts. Otherwise the plus 30 never lights. Right, we're done. Two things to do, are there not? We need to put some switch cleaner on the squelch control, and oh, we've done that, of course. Ballast resistor. Right, next problem is his mic. So we don't actually repair mics, but it looks like we are doing. So is it broken pillars? The mic says made in Japan on it, so I don't think it's from this version. For starters, it will need to clean the switch. I'll pause the video and go and get the service on. Right, I've done the squelch control. I'll just do this. The switch is set off so that I can work the switch. We haven't got broken pillars, which is nice. It's also knowing when to stop with the screwdriver, because obviously you could carry on screwing till you break things. Right, switch back on. Wallow. Switch the signal generator off. Let's put the walkie-talkie on, which has got a flat battery. Testing 1 2, testing 1 2, testing 1 2 1 2, testing 1 2, testing 1 2. Switch to PA. Testing 1 2, testing 1 2, testing 1 2, testing 1 2. So that does clearly work now. And finally, we'll just check whether the back in CB mode if the Roger bleep works. Yeah. Right, so I'm going to do the deviation with the test mic, and then we'll check it with the factory original mic. From cold, what's the power now? 4, good. I'll switch this off. Right, we'll plug into the other test set and see whether we're still at the correct deviation. Right, here goes. Yeah, that's right, about 2.4. Oh good, the Marconi test set isn't lying there. So we'll just see what the deviation is with the factory original mic. About 2.2. Tell you what, we'll just pop that up a fraction. It's very, very slightly lower than with the peak than it can be. That's now peaking at 2.4. So with our mic, yeah, it's 2.5. Good. Testing 1, 2. Right, turn that off. So it was 1.4 as it came in. Unbelievable. It's never been messed with. It's brilliant. It's now 2.2 to a peak of 2.5. I've ticked off the speaker. I've not even heard it yet. Right, I'll switch the set-offs as a precaution when putting the lid back on. Actually, I need to clean this with isopropyl alcohol, so I'll do that and we'll have to come back to the video. So I hope you can see that looks a bit better now it's been cleaned. I just hope I've left it long enough for it to still work. I think I've only left it 10 minutes. Right, we'll get these this put back on. Just not quite sure why this is soldered because it's usually on tags, isn't it? Contrast to the fake one. Right. That'll plug the aerial in. As ever, I will say it's an Antron 99 without the optional ground plane kit, just above gutter level on a single story building, broadside into a roof with concrete tiles on an apex. It's deliberately in that kind of position to not perform at its best. 1 nano, roger. Well, you'd think it was as deaf as a post, but it isn't.
Everybody out there, what am I? A 94 piece, all metric, no AF.
Right, we'll get that on the air test done. Mr. Chippy's raring to go. Thank you for watching the Amstrad Hong Kong Genuine 5999 one from about 1982.